In this video, we're going to use what we learned about the distance formula in the previous video to, to graph circles on the coordinate plane. All right, so let's take a look at an example. So let's suppose that we have a circle with a center at here. So we'll say the center, well actually let's not do that. Let's put it right here. So our center will be at -3, 2. And let's pretend that its radius is, well, maybe I don't know what the radius is, but maybe I know that the point right here, 1, 1, is on the circle. So we know that our circle is going to look something like this. I'll try to draw as best as I can, but something like that. Not very good. So one thing we would definitely want to know is the radius, because the radius is really the defining feature of a circle. So let's use our distance formula to figure that out. So I'm going to draw in a little triangle right here. And let's see, if I'm using Pythagorean theorem, then our vertical distance is right here, which would be just 1, and our horizontal distance right here would be 4. I could double check that, but this distance right here would be, let's see, our y value for this guy is 2, and the second y value is 1, so that's 2. Or sorry, 2 minus 1 is 1. And this distance down here, well, that would be 1 minus -3, which is 4. And so the radius in this case, which would be the distance between them, the radius is equal to the square root of, let's see, their difference, which was 1 squared, plus the difference in the y-coordinate, which would be 4 squared, which is the square root of 17, all said and done. So now that we know what the radius is, we could, again, draw the circle if I knew how to draw the radius and then, again, maintain it and draw all the way around. That's really bad, but you get what I'm saying. But what if I want to figure out, hey, this point up here, some random point with some x and some y, how could I figure out if that is on the circle? Well, let's figure that out. How do I know, or how do I check, if some random point, xy, which is, again, some point is on the circle? Well, let's take a look at here. In this case, our x-coordinate was, our example point right here was 1, 1. And so how would I figure out the distance between that point and the original, and the center? Well, what I did was I subtracted their coordinates. Now, in this case, I did 2 minus 1 to find the vertical distance, but I really could have done 1 minus 2, and that's probably what I should have done in the first place to get -1. And again, it didn't matter if it was -1, because even if I threw in a -1 into our distance formula, it's being squared anyway, so it will still turn out positive. And likewise here, I did 1 minus -3, which is definitely what I should have done. The reason I'm doing that is because if I wanted to now figure out how far away this xy point is from the center, I would just use the distance formula again. So the distance from xy to the center, xy to the center, which is again 3, 2, or -3, 2, would be, well, d is equal to the square root of the difference in their x values squared. So let's see, x minus -3 squared plus the difference in their y value squared. Because again, this is just Pythagorean theorem. Y minus 2 squared. If it's actually on the circle, let's bring that down here. If it's on the circle, then the distance that the xy point is from the center should be the same as the radius. And so if that's the case, then d should also equal the square root of 17. So when we put these pieces together, this should say that the square root of 17 is equal to the square root of x, let's see, minus negative 3 is really just plus 3, plus y minus 2 squared. Now, usually we don't like to, having the square roots on everything kind of just makes it not as pretty. So what I'm going to do is I'm going to square both sides. So I'm going to square that left side, square the right side. We'll get 17 equals x plus 3 squared plus y minus 2 squared. That would be our equation. So what does this mean? Let's wrap it all up here. If the point xy, if xy satisfies or makes it true, that's messy, satisfies this equation, this equation being this one in the purple box, then it lies on the circle. It lies, oops, the circle. And the cool thing about this equation is that it tells you everything about the circle. It tells you where the center is. Where was the center? Well, the center is really right here. That was the x-coordinate, negative 3 and 2. And now notice, when I subtract here, because I'm subtracting negative 3, it ended up being plus 3. So essentially, if it says plus 3, then that coordinate is actually negative, and if it's minus, then it really means the coordinate is it's positive. So it lies on the circle with center, negative 3, 2, and radius. So this is where you need to be careful, because right now, remember, this was the radius on its own. So now the 17 is its radius squared. And so the radius of this circle is actually not 17, it's the square root of 17. So we can generalize this by now saying, if I kind of take those ideas and just wrap it all up, the equation for a circle is really x minus a squared plus, not x, y minus b squared equals r squared, where AB is the center of your circle, and r is, of course, the radius. Before we end, I think it makes sense to kind of see where each of these pieces in the equation come from. So let's take a look at a circle here. So let's pretend my center at this point is, I don't know, right here. So this will just be our AB. Okay, and the circle is over here. And I'm going to draw the radius right here. So here's the radius. The point out here is some point xy that is on the circle. And so if I'm, again, the distance formula and all this just comes from the Pythagorean theorem. So if I want to figure out, draw a right triangle, I'll draw this little right triangle right here. And so this x minus a, that is this length right here, x minus a. And the y minus b is this green length here, y minus b. And so this is essentially leg squared plus leg squared equals hypotenuse squared, just like we've been working on since April. Or sorry, not since April, since January pretty much.